Cool. All right. So welcome in the recording. So to begin today, let me get the PowerPoint up and going. I'm going to point out something from last time. Now, if you weren't here last time, that is okay. All I am doing is pointing out just sort of something that follows from what we did. So let's come over here and screen share. All right. All right. Everything's up and running. Okay. So like I said, I'll tell you exactly what it is last time that I want to point out. I'm not really going to do a call and response on this. I'm just going to kind of point something out to you guys for you to think about, and then we'll get into today's topic. So last time we used the factorial, and I've defined that right here, the n factorial. You just take a number and multiply it all the way down to 1. So 5 factorial is 5 times 4 times 3 times 2 times 1. We use that to come up with, like the big question was 20 consecutive composite, which means not prime, integers. So an example of consecutive non-prime integers would be like 8, 9, 10, and then we'd have to stop right there because as soon as I go to 11, that's a prime number, 7 is prime. So this would be a sequence of 3 consecutive prime numbers. And we were interested in how long of a sequence of consecutive prime integers could we come up with. And we used factorial to do 20 consecutive ones. We did 20 factorial plus 2, plus 3, all the way up to plus 22. And we talked about how we know that that actually works, that all of these are not prime integers. So based on that, right, note that we didn't have to use the smallest number, right? We used 20 factorial. We wanted 20 consecutive non-prime integers. But really, we could have used any larger number to do this. We could have used, say, 100 factorial plus 30, because 30 is a factor in here, right? Because 100 factorial, you just multiply 100 all the way down. 31 is also going to be in that. So that's a common factor. And all of the numbers up to 49, right? And from 30 to 49, that gives you 20. Remember, you're counting the 30, gives you 20 consecutive composite integers when you add that to 100 factorial. So we could have used any very large number. You could use 101 factorial, that's fine. And it would still work. Now, we were talking about doing a list of 20. But the thing is, right, the whole point was, and this is the point of most math, you want the thing that works in general, not just the thing that works for the specific numbers in front of you. We could construct any number of consecutive composite integers we want. In other words, if you say, I want a sequence that's this long, if we use the factorial, we could construct one that long. For example, if we wanted 1 trillion, right, that's what 10 to the 12 is, right? That's a 1 with 12 zeros after it. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That is 1 trillion. So if we wanted to do 1 trillion composite integers, we could do a trillion and 1 factorial plus n, and then just let n go 2, 3, all the way up to this number. So any number you give me, I can make a sequence of composite numbers, as many of them as you want, back to back. So here's a question. If that being the case, what does that tell us about the distance between prime numbers, right? If we can make a sequence as long as we want of non-prime integers, we can always do that. And we then ask the question, how far apart can prime numbers be, right? For example, if we had 7 and then 8, 9, 10, 11, 7 and 11 were 3 integers apart, right? There were 3 integers in between them. And when you look at the chart for, if you go up to 50 and you just kind of hunt and search for how long of a sequence of non-primes can I come up with, the most we got was 5, right? But in general, because we can come up with as long of a sequence of composite integers as we want, we can get a sequence of not primes, and we can make that as long as we want if we use this factorial approach. Then what that tells us is that this distance can be as big as you want. So if you want, hey, I want 2 primes that are 32,500,003 numbers apart, at least. You can find two primes that are at least that far apart, because you would just take that number I just said, factorial, and do this trick that we did before. And so, given that, could there be a finite number of primes? I'll be silent for just a second. Like, just think about that, and then I'll tell you. And then we'll get into today's stuff. But if you think about that, if that's true, you tell me how far apart you want some primes. I can always put them that far apart. There can't be a finite number of them, right? There would have to be an infinite number of primes. And the thing is, some of you may already know, yes, I know there are an infinite number of primes. That's cool. But really what's more interesting is, why does this tell you that, right? Because maybe you know some other reason. This tells you that because if there were a finite number of primes, right? We're not going to do, this isn't a formal proof, but let's say I've got prime number 1, prime number 2. Let's suppose there's 100 primes. Well, then I could just take prime number 1 and I could just look and I could see who is this furthest away from, right? And write that down. So prime number 1, maybe it's the farthest away from prime number 3 or something. I write down how long that is. Then I go to prime number 2 and I check how far away is prime number 2 from everyone else. And I write it down. And so I'll have a list of how far apart these 100 primes can be from each other. That's going to have a biggest number. I grab it and I say, this is the furthest apart any two primes can be, because we've got a finite number of them. Here they all are. Look, this is the furthest apart they can be. But we already know that we can make a sequence of not prime integers as long as we want. So in other words, given any two, you can always find two primes as far apart as you want, right? So that's kind of something that follows from what we did before. So something you should always do when you learn something new in math is, like last time, we did this factorial thing and made sequences of not primes, sequences of composites. But you should kind of ask yourself, okay, but so what, right? Why is that interesting? What does that tell me? And one of the things, there may be more things this tells you that I didn't think of, and you can go think about it. But one of the things this tells you is that there cannot be a finite number of primes. So that's just a comment on what we did last time, something that follows from that. If you weren't here last time, don't worry about it. Just like you have factorials, we can make really long sequences of not primes. That tells us there has to be an infinite number of primes. Okay, and it's a different proof than the one you usually see. So today's topic is actually this. Did anyone have any questions or comments on the comment from what we did before I get into today's topic? Okay. Is anyone confused by what I said about what happened before? Need clarification on anything? Okay. Okay, so if later you decide you do have questions on that, we always stay a little bit after and chat for like 10 minutes or so. So let that sit in the back of your mind. So today we're going to be talking about this. We're going to be looking at writing 3 to the n as a sum of consecutive integers. And then after that, we'll look at writing 2 to the n as a sum of consecutive odd integers. And notice that for 2 to the n, I have to say odd, but for 3 to the n, I don't. That's a bit weird. Well, we'll see what's going on as we go. Okay, so some of what's going on there will become apparent. Now, at the end of last session, I did a warm-up with exponents, right? So I'm going to go through this. I'm going to go past what we did at the end of last session. I'll write it out. If anyone has questions, jump in. And then once I'm done with the exponent review, right, that we did last time, then we'll keep going, right? So just as a reminder, right, if you have exponents, the way that you read that is it's repeated multiplication, right? And the only reason I'm just jumping in and explaining this and not doing a answer back and forth thing is we did this at the end of last session as like a warm-up. So just as a reminder, right, 2 cubed, the way you interpret that is 2 times 2 times 2, right? So powers mean repeated multiplication. So this would be 8. This one would be 4 2s all multiplied together, right? And if you're being really sneaky about this, we already know what 3 of them is. It's 8. And then 8 times 2 would be 16. And then this, right, you would have 3 2s, and then you would have 4 2s. Okay, so we would have 8 times 16, which is 128. And the shortcut, right, is that, well, what do I actually have if I drop the parentheses here? I've got 1, 2, 3, 4, 5, 6, 7 2s. So the shortcut is to simply add those exponents. So this would be 2 to the 3 plus 4 or 2 to the 7. So that's a shortcut for working with exponents, right? So this is what exponents are. This is a shortcut for multiplying them. The next thing is if you have fractions, how do we work with exponents? Because we're going to be working with exponents for those questions that we're going to be doing today. And the convention is that this would be interpreted as 2 to the first power. And since it's in the bottom, right, remember that writing a positive number up here represents repeated multiplication. So the opposite of multiplication is division. So I would write that with an exponent by using the opposite of a positive number. I would use a -1 right there. And similarly here, I would write this as 2 to the -3. Okay, so hopefully this is just review. If not, ask questions, right? Ask for clarification. So similarly, if I wanted to work with this, if we only do what I showed thus far, we would write this as 2 cubed times 2 to the -4, because it's in the bottom. You add exponents, so you get 2 to the 3 minus 4, which would be 2 to the -1. The shortcut is that when you divide, you subtract, so you'd have 2 to the 3 minus 4, and really you're just right at that step. The shortcut saved you one step. So when you divide with exponents, you subtract the powers. Okay. Okay, and now we're at where so that right here was where we were at last time. Now, there's a little bit more exponent review, but we didn't do this last time, so this is where we're going to start. So anyone at this stage, can anyone tell me what the greatest common factor of 2 cubed and 2 to the 5th is? You can just unmute yourself and jump in.
8.
Yes, that is correct. So because 2 cubed is 8, right?
Yeah.
2 to the 5th is 32. Agreed. Can you tell me using this notation, though?
2 to the 3rd.
Third, right. So I circled it. So in other words, between 2 to the 3rd and 2 to the 5th, right? If we're pulling out a greatest common factor, one way you could look at that is that you have 2 to the 3rd plus 2 to the 3rd times 2 squared, right? That's what 2 to the 5th is. And then you could factor out the 2 cubed. Okay, so because the question was just what is the greatest common factor, it's fine to just observe it's the smaller one, but we're going to be doing a lot of arithmetic like this moving forward. So I just want to point that out. But yes, in this case, the greatest common factor is 2 to the 3rd. Let's see, great. Right. Careful, because you have greatest common factor and least common multiple, and they're not the same thing, right? They're like the reverse. So the least common multiple of this would be 2 to the 5th. There's a question I got in chat. So very good. So we're not going to be concerned with least common multiple today. We're going to be concerned with greatest common factor, I believe, for everything that we do. If LCM comes up, I'll go more into it. Okay. Now, based on that, what do you think the simplest possible way to write 2 to the n plus 2 to the n is? Right? So take a minute to think on that. I will let Maria call on someone.
Make sure you're sending your answers to me directly. Me or Connor would be fine.
Okay.
Whenever I'm ready, or
In fact, go ahead if you've got any.
I got a couple. Andrew, do you want to share your answers?
I got 2 to the power of 2n.
Okay, can you explain to me how you got that?
Well, in the beginning, you said that the shortcut to adding to doing exponents is if the exponents have the same base, you could just add the exponents together.
Ah, so be careful. So if we had 2 to the n times 2 to the n,
Oh, okay.
yes, then the shortcut is to add the exponents. So that would be correct. But we don't have times. We're actually adding these. Does that make sense?
Yes.
Okay.
Logan, you want to share what you got? Oh, wait, no, that's the same thing. Sorry. I meant Amal.
Well, yeah, I factored out the 2 to the n, so you get 1 plus 1 basically, which is 2. So 2 times 2 to the n.
Okay, good, good. So let me write that down. So 2 to
Or
the
wait, well, you could simplify that more by saying 2 times, well, 2 to the power of n plus 1.
You got it. Yes. So just to write out what you were saying, that's what I was looking for. So this is 2 to the n times 1 plus 1, because I factored that out from both of those terms. This is now 2 to the n times 2, and you could think of the times 2 as times 2 to the 1. Now it's multiplication, and precisely what we were saying before, what Andrew was saying, the shortcut is now you add those exponents. So this is 2 to the n plus 1. Okay. Anyone for which that didn't make sense, or does anyone want to ask anything about that?
Wait, how do you factor out 1 plus 1 exactly?
Sure. Let's write that out in a little bit more detail. So remember, when you have multiplication and you're pulling stuff out, the ones can be kind of sneaky, right? So I could write these 2 to the n and 2 to the n times 1 are the same thing, right?
Oh.
Yeah. And then I pull out the 2 to the n and I've left 2 ones are left behind.
So wait.
Mhm.
Let me try to make sense of that.
Yeah, so right underneath it, suppose I had 2 to the n times 3, just so it looks different, plus 2 to the n times 5. Since they both have 2 to the n, you would just take that out, and what would be left behind would be a 3 and a 5, right?
Yeah, that makes sense.
Here they're ones instead of 3 and 5.
So yeah.
Yeah, same thing happens. Yep,
That's clever.
indeed. But you'll notice a lot of times we'll like skip it, but yes, that's what's happening. Cool. All right, so we've got our tools, we've got our power rules, our exponents, how to work with them. Let's start using them. Okay, so sudden jump in what we're asking for, right? So we may or may not be immediately using power rules, but let's start easing into the questions I said we're going to be solving. So express each of these as a sum of 3 consecutive integers. Remember, consecutive means back-to-back numbers, right? Back-to-back integers. So everyone take a couple minutes to think about this. If you can solve all 3, that's great, right? But whichever ones you do solve, go ahead and send them to me, Maria, or Connor. Then we'll call on someone. Give it like 2 minutes. Of course, if you need clarification on what's being asked, feel free to ask us.
And just to point out, a lot of mathematics, particularly questions, word problems, you have to make sure you're reading it carefully. So here it wants you to express each of these following numbers as a sum of 3 consecutive integers.
Yes, so remember what sum means. It means addition. So for 9, for example, what we're looking for is some number let me not get too close to the notation we're looking for. Some number plus some other number plus some other number, right? That's what we're looking for. The conditions is they need to be consecutive integers, right? So take a minute to think. And then Connor, I'd say in about 30 seconds, if you've got any interesting ones, I'll let you call on someone. Okay, let me actually see if I can switch colors. Yeah, I like that color better.
All right, Aiden and Brody, do you guys want to share your answer?
Sure. So, what I did was that, so I did 9 divided by 3 to find the middle term,
Okay.
because if, like, let's just say k is the middle term, so it's k minus 1 plus k plus 1. So like the ones cancel out, right? So it's just 3k. So that's how you find the middle term. So I just got 2 plus 3 plus 4 for 9, and then did the same thing for 27, and I got 8 plus 9 plus 10. Then I did the same thing for 81, like divided by 3, and then I got 26 plus 27 plus 28.
Okay, nice. So what he was saying with the k being a middle term is, and this is what I started to almost give this away because I wrote a k here and then I backed off. So we want a sum of 3 consecutive integers. So what he was saying is, well, let's say that it's k minus 1 plus k plus k plus 1, right? For k being something, whatever it is, some number, that's going to be 3 consecutive integers, right? If you give me a number, you step back, you step forward, that's a list of 3 consecutive integers. And then what he did was he said, well, we're going to have 3 of them. Let me just divide my number by 3, and that tells me what k is going to be. So we had 3 minus 1, which is 2. He had just 3. And he had 3 plus 1, which is 4. And so 2 plus 3 plus 4 indeed adds up to 9. And so this is a sum of 3 consecutive integers giving us 9. And the way to see that you get this, 9 over 3 equals k, right? If you actually add these guys up, you have k plus k plus k, that's 3k. And then minus 1 plus 1, that just goes away. So you have 3k equals 9, which if you solve that, if you divide both sides by 3, you get k equals 3, right? So that's what he was doing. And he simply did that for the rest of them as well. So taking this number, dividing it by 3, you got 9. So taking a step back, he got 8, 9, and 10. For 81 divided by 3, you got 26. Now you said 26, 27, and 28. Yes, okay, because your k actually here was 27. There we go. I was writing down literally the words, but what you would do is you'd get 27. You take a step back, you get 26. A step forward, you get 27. Or staying where you are, you get 27. And then a step forward, you get 28. And so all 3 of those numbers, he expressed them as a sum of 3 consecutive integers. Now, some of you may have just kind of guessed, right? You may have just kind of intuitively trial and errored to get 2 plus 3 plus 4. That's fine, right? Trial and error, if it gives you an answer, that's a starting point. That's okay, that's the answer for this one. That may be a bit harder as the number gets bigger, right? So once you have this general process, okay, now it's not so bad if the number's larger, right? Because I just do the same thing I was doing. Does anyone have anything that was different, or do they have any questions on anything here?
Did anyone solve this maybe a little bit differently?
Yeah, if you got like this, but you did something totally different, would love to hear or see that as well. Okay. Okay, it's making sense to everyone, I hope. All right, that's everyone's on the same page. Okay. Okay, so let's jump up a bit, right? Express 27 as a sum of 27 consecutive integers, right? So if you were just guessing, right, just trying to come up with 3 numbers that worked, that's kind of doable. But now 27 of them, a list of 27 numbers all added together, how are we going to do that, right? So take like 3 minutes to think about it, right? Think of what we did here and see if you can come up with a way to write 27 using 27 consecutive integers, using a sum of 27 consecutive integers, right? So take a bit to think. Again, one of us will call on someone. Remember to send us your answers when you have them. If you have questions about, what's being asked. Okay, and remember, integers are allowed to be negative. Just a reminder. Okay. So I've gotten one answer. Connor, Maria, how many answers have you gotten so far?
Nothing so far.
0. Okay, then let's give it a little bit longer. I want everyone to have a chance to think about this.
Maybe give them a hint.
Okay. Okay, so let me I'm like giving 10 seconds and then I'm going to give you a hint. So warning, a hint is coming. Okay, so incoming hint. Maybe what you could try to do, right? If you're not sure how to start this, feels like it's a little too out of left field. Here's what you could try. If I added 1 over and over and over again, if I added it 27 times, right? Those aren't consecutive integers, but that's a list of 27 integers, right? 1 plus 1 plus 1 plus 1 plus 1. That gives me 27. Maybe now that I have that, I can try to adjust. Maybe I can take each one of those and either add or subtract something. It doesn't have to be the same thing, right? Can add or subtract something to each of these. And maybe that's supposed to be a plus minus. Maybe that will get me somewhere, right? So there's a hint. If you're having trouble getting started, maybe look at 27 ones all added together and see if you can adjust that to get what we want. Let me correct my typos here, not doing plus 1.
All right, I got one answer so far.
Okay, okay. Okay. Let's give it 30 more seconds and then I'll pick someone because I've got a couple answers. Okay, Got the same answer from. Okay. So, Anisha, would you like to share what you got?
Yeah, I'm not really sure if it's correct, but so I divided the 27 by like the 27 consecutive integers,
Mhm.
which is 1. So like the middle term would be 1, and then I just want like 13 above and 13 below.
Very nice. Okay.
So it would be from like -12 all the way up to 13.
Okay. So let me unpack what you just said, because yes, you're following the approach from before. There's one little thing, but we're about to see it in a second. So she did the same thing as here, right? We wanted 3 consecutive integers. So that's why on each of these, I wind up dividing by 3. Now we want 27 consecutive integers. So if our middle term, I guess I'll write it here, if our middle term is k, and I need 27 consecutive integers, then the next one would be k plus 1. The one beforehand would be k minus 1. And I would just keep going in both directions until I have 27 integers, right? So for 27, this would be like the 0 position, and that leaves 26 over. So I would need to go 13. I would need to go 13 in both directions.
Also, I realized my mistake. It would be 14, not 13.
Very good. Yes. That is a common, that happens all the time, that specific error. In computer science, it's called the off by 0 error. Because as human beings, for example, let me see, where was it? There was a thing I said, and I would like to point it out again. Right here. So I was expecting, when I said that from 30 to 49, there's 20 of those, I was expecting some people to have kind of a, wait, isn't that 19? Because 49 minus 30 is 19. The thing is, when you do 49 minus 30 for that, it's like you're not counting the first one, but we are counting the first one. So you would have to put it back in, right? So that's a common psychological thing that gets people. So I wanted to emphasize that on purpose. Okay, very good. So we have this. This goes all the way down to k minus 13. And that needs to equal 27. And so the beauty of doing it this way, of writing it in both directions when you can, is that all of the positive and negatives cancel. The 1s cancel, the 13s cancel when I'm adding this all together, and the 12s would cancel. And so what you'd wind up with is 27k equals 27, from which you get that k equals 1, right? So actually, my hint was kind of skipping steps. My hint was, well, if you do exactly the same thing we did before, you get a k of 1. The difference is we had to go further because we want more consecutive terms. And just using this formula, let me erase the ones above so I have room to write here. So using that formula, you get your list of consecutive integers. Pen, which if you just plug in k equals 1, 1 minus 13 is minus 12. And the next one would be minus 11. And then you get up to k equals 1. So the previous term would be 0, and then 1, and then 2. And when you get up to here, you wind up doing 13 plus 14, because you have 1 plus 12 and 1 plus 13, giving you those terms. So this right here would be your list of 27 consecutive integers that if you add them all together, you get the number 27. Very good. Does anyone have any questions on that? Or did anyone do it differently? Right. Look at chat. Okay. Okay. Again, don't be shy. If anything doesn't make sense or you've got questions, please ask them.
There's always a multiple way of doing problems. You know, the longer way would be choosing combinations of 3 numbers that add to 27 and then finding out if you need to take some from the left or right. That would probably be the long way.
That's true. Yeah. So yeah. So since we had seen how to do it for 3 consecutive integers, we could try to then break up our sums as sums or something like that, right? There's all kinds of things you could try. Whoops, went too far. Okay, well, if there's no questions here, I'm hoping everyone's on board because we're going to ramp up, right? That's what we do. We start simple, build our tools, keep climbing. So how about if I wanted to express 81 as a sum of 27 consecutive integers? Okay. So we'll give everyone about 2 minutes to try this one. And again, use what you've seen. So if you were uncertain how to do this one, but you understood this, right? And this made sense to you, see if you can adapt it now. See if you can use it for this next one. So give everyone a minute to do that one.
And also just keep in mind how we did the last one. If you need to go back to the other slide, just let us know.
So actually we'll go back, but remember we're expressing 81 using a sum of 27 consecutive integers. Just a reminder of how we did the last one.
All right, I got 2 answers so far and they're slightly different. Just let me
Okay.
know when you're ready.
Go ahead. Yeah, because this one's very similar. So yeah, go ahead.
Anisha, do you want to share yours? And then I'll call on one other person.
Yeah, so I divided 81 by 27 and I got 3.
Cool.
So I got the middle number as 3 and I went 13 above and 13 below. So I got from -10 up to 16.
Okay, so let me just write down the formula that you're using and then your sequence right underneath. So give me just a second, Maria, before you just write this down, k minus 1 and then k and then the same thing in this direction. If at any point someone wants me to write slightly more legibly, you can just yell at me. It's fine. I will not be offended. Okay, so using the same formula, but k is 3. So 3 minus 13 is -10. The next one is -9. We get up here to 2, and then 3, and then 4. And we're up here. So what was the other possibility?
Andrew, do you want to share yours?
I got the consecutive numbers from -14 to 17.
Okay, can you elaborate how you got that?
Well, I used the same thing as you did the last question.
Mm-hmm.
I divided 81 by 27,
Mm-hmm.
and I got 3 as the middle number.
Mm-hmm.
So I just went 14 in both ways, or sorry, it was -13 to +16.
-13 to +16. Okay, so I'll just scratch that out. Okay, but okay. So -13 to so you agree here to up to the +16. Once again, can you elaborate on how you got the -13 as your lower thing?
I made a mistake.
Okay, so but does it make sense?
Yes.
Okay, so because it was 13 down, it was like, oh, -13. But it needs to be -13. Where's my pen? It needs to be -13 from whatever your k number is, right? So since it was 3, you would do 3 minus 13 down here. Cool. But you were doing the same thing. It's the same idea. Yes. Does anyone have any questions on this?
Does it make sense more now, Andrew?
Yes.
Yes. Okay.
Cool beans. Cool beans.
Is anyone still confused about it or would like to see another example or talk about it more?
Why 13 though?
I'm sorry?
Why the number 13?
Why the number? Oh, good question. So we want 27 consecutive integers. So if I'm going to start from a middle number and go in both directions, right? So I need there to be 27 things overall. This counts for 1. Then going up in this direction, this adds 2 on each side. And then I keep adding on both sides. So this is 27. I've got 1. There's 26 left over. Half of 26 is 13. So I put 13 on both sides.
Oh, okay. I was doing 81 consecutive integers.
Ah, okay, I see. So that a lot more of them, right? Okay,
Yeah.
Cool beans. But that's a good point. Let me emphasize. If you see consecutive integers, you could do, let me change my pen color. You could do green. You could do k and then k plus 1. And you could go all the way up to k plus 26. Why did I do 26 and not 27? Count it. The 0 is the first one, and then the 1 is the second one, right? This is the off by 1 thing. This is what haunts computer scientists all the time because everything starts at 0, so 0 is the first place. But regardless, this would be 27 consecutive integers, and you could do this. The reason we've been doing it where we add stuff on both sides is that, again, when you add everything, these all cancel off, and you can just find your k. So that's why we've been doing it that way. Doesn't mean you can't do it another way. It's still doable like this. It's just a little bit more algebra is involved if you take that approach is all. So that's to say there are multiple solutions. There's one other approach.
Okay.
There are. No problem. All right. So here we go. Now the numbers are getting too big to write them out too explicitly. Now we want to express the number 3 to the 7 as a sum of 9 consecutive integers. Now 3 to the 7 is some number. You could put it in the calculator, get that number, but frankly, knowing what that number is not going to be helpful. It's irrelevant to what we've been doing. So keep that in mind. I don't really care, and I personally don't know what 3 to the 7 is. It doesn't matter. I can still answer this question using the same techniques we've been using. So give it a try. Try to express 3 to the 7th as a sum of 9. Notice we're doing fewer consecutive integers here, right? So we're balancing the difficulty a bit. Try to express 3 to the 7 with 9 consecutive integers. And Connor, I'll have you call on someone once you've got an answer or two. Whoops. Okay. Which means on the next one, I'll call. Okay. Have you gotten any answers yet, Connor? You have? Okay.
Amal, do you want to share your answer?
Oh, yeah, okay. So you said there's 9 consecutive integers, which is 3 to the 2nd power. So that's the number of integers. And then if you divide 3 to the 7 by 3 squared, you should get 3 to the 5th. And
Okay.
then since there's 9, you should subtract 4 to get the least integer, and then add 4 to get the highest one, and then 3 to the 5th should be the middle.
Very good. Okay. So to take what you said and to make it match as strictly as possible what we did before, right? Patterns. The reason you did 3 to the 7th divided by 3 squared is because that's given you your middle term, right? This is what you said. I'm just repeating for everyone. So that's our middle term. Because we're going out 9, that means I'm going to go 4 in each direction, right? Because my middle term is 1. 9 minus 1 is 8. I need to go that half of that in each direction. So we are all the way down at 3 to the 5th minus 4. Again, this is k minus 4. 3 to the 5th minus 3, and so on. Let me put parentheses around these, right? Well, actually, I could just write all of these out. So let me try to erase and do that, just so we can explicitly see it. So 3 to the 5th minus 1, plus 3 to the 5th, and so on. Any questions on this? Okay. If you have any questions about, can we do, like those questions are good too, right? Any questions at all? Does it make sense?
Yes. Is it okay if you, because I simplified it.
Mm-hmm.
I actually found out what 3 to the 5th is, and then I simplified it. Is that fine?
So what you would then get is 3 to the, oh, you mean you wrote these numbers, that's fine, yes. Yeah, so that is also fine. You're about to see on the next question why we haven't been bothering to do that, but that's perfectly fine. That would be full credit. Yes. Okay. So I just gave something away. Wait, why haven't we been caring about this? So everything's had numbers in it, right? What do all math instructors eventually love to do? Take away the numbers, of course. Put the alphabet in there. So everything we just did with all of these examples, can you now do it in the abstract? Can you express 3 to the n as a sum of 3 consecutive integers, where n is just any integer, right? Could be negative a million, it could be negative 2, it could be negative 1, it could be 0, it could be... See if you can give me a formula. Remember, we're just wanting to use 3 consecutive integers now. And I will call on someone. Okay, and we are going to just consider the case that these are positive, actually. The negatives will be too finicky. Yes. Okay, cool. Okay, so I've got some answers and I'll call on someone, but let's give just it's like half a minute. Okay. Okay, so Raphael, would you be willing to share what you got?
Yeah, sure. So what I did is to find the middle term, I divided 3 to the power of n by 3.
Cool.
So then I got 3 to the power of n minus 1.
Very nice. Yes. As you said, that's to find your middle term. Okay.
Yeah. So then I just did 3 to the n minus 1 plus 1 and 3 to the n minus 1 minus 1.
Very good. So I'll write them in the order you said. So that's your middle term. The next one would be that plus 1. And then the previous one would be that minus 1. And that is 3 consecutive integers. Right. And actually, just as a comment, right, because up here I was just thinking, oh, n is an integer, but let's be more careful. We need n to be 1 or bigger, right? Because otherwise we'd have 3 to a negative. We'd have fractions. We can't write fractions as integers being added together, right? So our n needs to be 1, 2, 3, or so on. So I'm just going to go ahead and fix that up here. Did anyone get anything different, or does anyone have any questions on that? No? Okay. So you may have noticed something, and if you haven't, I'm going to kind of point it out. You may have noticed that everything had 3s in it in terms of powers, right? Like if we look at, okay, not that far back, but if you look at this, this was 3 squared, 3 cubed, 3 to the 4th, right? These are all powers of 3 that we're working with. 27, 27, that's 3 cubed, right? Again, 81 and 27 was involved, 3 to the 7 and 3 squared was involved. And then here it's more abstract, but 3 to some natural number, right? So, and we had a list of 3 consecutive integers. So this begs a question, right? So far, we've seen 3 to the n written with different amounts of consecutive integers. In other words, different length sequences of consecutive integers being added together. So can we write 3 to the n as a sum of any number of consecutive integers? In other words, can we have any length we want? Can we have 3 to the n equal to, say, k minus 2 plus k minus 1 plus k, and then plus k plus 1? Let's stop there, right? Could I do 4 consecutive integers? Could I do 37 consecutive integers, right? That's the question. Think about it for a moment. Right? Let's let everyone think about it. You don't have to give answers in detail quite yet, but just ponder this. Can we write 3 to the n with any number, any length of consecutive integers that we want? And keep in mind, if you think you do have an answer, if you think it's yes, prove it or tell me why. If you think it is, and this should be +1. If you think it's no, again, tell me why, right? You don't just guess. Give me reasons. If all you have is a guess, feel free to share. If you've got an intuition, but try to have some sort of explanation behind the intuition. Now, this is the abstract case. Let's suppose 7. Let me give you an actual concrete number. Can you do it for 7? Let's be really specific. 7's not a power of 3, right? See if we can do it. Okay. So I've got an answer. Let's wait and give everyone a chance to think about it. Mm-hmm. Let's see. So Connor called and then I called. So Maria, whenever you're ready, feel free to call on someone.
Still waiting on some responses.
Okay. Remember, guys, Maria exists.
I do. I'm here. Hi.
Okay.
How are you doing? Is it just me who's getting all the answers?
Oh, have you gotten a bunch of answers just now?
Just a few.
Just a few? Yeah, I've gotten 3.
Okay.
Do you have anyone that you haven't called on today yet?
Michael.
So I kind of guessed. And I said no, because 7 is not a multiple of 3 to the n. Because if 7 is, because 7 doesn't involve 3, like you can't multiply 7 and get 3.
So
Like,
in other words, yeah.
When you multiply 3 by itself, you can't get. Yeah. You see what I'm trying to say.
Yep. Very good. Another way to say is 7 doesn't divide 3. So now, like you said, you backed up what you're saying. Now you're saying it's because 7 doesn't divide 3. That's true, 7 doesn't divide 3. Can you elaborate why that's a problem, though? Or let me say this differently. Suppose I just don't get it. How would you write this out to show me why that's a problem, why it's an issue that 7 doesn't divide 3?
Well, we're trying to find integers, and when you do 3 to the n, it's just 3 times 3 times 3 times 3 times 3, so on and so forth until you get n's value. But no matter how many times you multiply by 3, you will never be able to get something that will be divisible by 7. And if it's not divisible by 7, then it's not an integer.
Very good. Okay. Does anyone else have any other comments, or do you maybe disagree, or does anyone have something else they want to share before I spill the beans?
Wait, I have a question. So let's just say it's like 7. How can you express 7 in like 2 consecutive integers, right? So it can just be 3 and 4.
So if I do that, yeah. So this right here in words, I have expressed 7 as
my
the
bad.
sum of 2 consecutive integers. So I can express 7 as the sum of 2 consecutive integers, but the question is, can I write 3 to the n as a sum of 7 consecutive integers, right? So I'm not actually adding the number 7 in, that's the number of things I want to add. Does that make sense? It's okay if the answer is no, right? But
Oh yeah, it makes sense.
okay,
Because every odd number can be represented by the sum of 2 consecutive integers.
that's true. Very good. Actually, yes. That's the general statement. Okay, so let me, in the wording I used a moment ago, let me spill the beans a bit. So what Michael is saying, no matter what, this is not going to be a multiple of 7, so it won't be divisible by 7, right? But let's try to apply what we were doing before. So if 3 to the n is expressible as the sum of 7 consecutive integers, then that would mean we would want to have a middle term and then add 3 integers in front and 3 integers behind, right? Because then that would be a sum of 7 consecutive integers. So to see if we can do it, let's try to do it. So here's the 3 in front, right? And then here's the 3 going backwards. So go ahead and take a minute. I want someone to tell me what you get for k, what your middle term comes out to be if you do this, if you solve this for k. Right? Because this is a sum, right? We've got like terms over here. What happens if I add all those together? What do I get? Okay. Yeah, Amal, do you want to go ahead and share?
Yeah, it would be 7k plus 0.
Yeah, it would be 7k, because if you rearrange these, there's 7 of these k's, so there's 7k, and all of these numbers canceled. Let me write that down explicitly, but we have -3, -2, -1, +1, +2, +3. You can see that all of those just cancel out. And now, excuse me, now what Michael was saying comes up. To solve for k, you divide by 7, and there's your k, but 3 to the n will never be a multiple of 7, because 3 to the n is just a bunch of 3's all multiplied together. That's not an integer, right? So if I tried to plug that in, that's not a sum of consecutive integers, because this isn't an integer at all. It's a rational number, right? It's a fraction, a ratio. So no, we can't do it. So we cannot. Any questions on that? Does anyone have any questions on that? Okay. Notice that reasoning. Proving yes or no directly is kind of hard. How about I just assume I can, and if I'm wrong, something will break. Something will show me that it can't be done. That's a very common thing to do in mathematics. Okay, so here's something else that's very natural and common to do in math. We had a statement, we wondered if it was true. It wasn't. We can't write 3 to the n as a sum of 7 consecutive integers. So more generally, we cannot write, the answer to this is no. we cannot write 3 to the n as a sum of any number of consecutive integers. The answer is no. But as a mathematician, I want to know all things that are true. So, okay, this isn't true. Can I rephrase it? Can I say something that will be true? Maybe I can do that. So, consider this. Consider the statement 3 to the n can be written as a sum of blank consecutive integers. What types of numbers do I need to put there in order for this to be true? All right. So think about it we'll give it a minute. That should be enough. Because it's kind of already been said. It's like a hint, but give it a minute to think about it. And one of us will call on someone. Okay, so I've got answers, but they're all from people who have already said things today. So let's see. Connor or Maria, if you get someone else, call on them as soon as you see them. If not, I think we're
You
at
want
the...
someone different?
Yeah, if you've got it. If not, I think we're at the stage I'm going to pick someone, whether they send me anything or not.
All right. You have to excuse me. I don't know how to pronounce your first name, but last name Francis. You want to volunteer?
I said it was multiples of 3, since it's the numbers 3n.
Okay, multiples of 3. Now, let's elaborate a bit. Multiples of 3. So 3 to the n can be written as a sum of 3. And when you say multiples of 3, what do you mean? So for example, 6 is a multiple of 3 and 9 is a multiple of 3. Are both of these okay?
Yes, I think so.
Okay. Okay, let me see just for a second because I saw. Logan, do you want to share what you just said to me in chat?
I think it would be the squares of 3 because the n is in an exponent slot, so it can only be square root or squares.
So when you say squares, what you mean actually is just any power, right? So squares, cubes, is that correct? Or am I putting
Yes.
Okay. So the reason 6 is a problem.
Yeah, I believe so.
Okay. The reason 6 is a problem is the same thing as what happened over here. Notice that if we tried to do 6 consecutive integers, right, then we'd get something like this. And if we do 3 to the n over 6, right, the 3 goes in, no problem, but the 2 is not going to divide into what's left over. It's not going to divide into the 3 to the n minus 1. So having, scoot over here, having multiples of 3 is the right direction, but not quite strong enough. It has to be powers of 3. Does that make sense? Okay.
Yes.
Okay. So let's see, I've been using k a lot. I guess I'll use k here. So really, 3 to the n can be written as a sum of 3 to the k consecutive integers would be fine, right? Or 3 to the l or whatever, some natural number, right? As long as, right? What's a possible problem with this? Anyone can jump in. Is it any natural number? Let's say n is fixed. Let's say n is 11. So I've got 3 to the 11. Can I write this as a sum of any power of consecutive integers, or is there some restriction on k here?
No, because k has to be less than n.
Why?
Because if you divide 3n by 3k and k is larger than n, then it will come out to a fraction.
Very good. So if I have 3 to the n divided by 3 to the k, that's the same thing as 3 to the n minus k. And what he was saying was that if k was bigger, this would be a negative number, which would be a fraction, right? Which is not an integer. So we also need k to be less than or equal to n. Very good. So, so all that really remains here is to prove that that's true. Okay. So, yeah. So let me do this. Let me present just an easier case right quick, and I'll leave the proof to you guys to do at home. If there's time at the end after we do the 2 to the n, we'll come back to like the formal proof. But let's consider the case where k is equal to n. So suppose they're equal. And give me 1 second. Okay. So if k equals n, then we have 3 to the n is equal to, so what are we doing? We were saying, can 3 to the n be written as a sum of consecutive integers, right? So here I was using k and writing all of this out. Now, suppose n actually equals k. So we want to write 3 to the n using 3 to the n integers, right? And so what I would have is I would have my middle term just being 3 to the n. Sorry for 1 second, something's throwing me off. Apologize. Okay. Go back here. 3 to the n is sum of 3 to the k consecutive integers. This time it was 7. Here we go. So if you set this up, then you would have 3 to the n, because we want to write it with 3 to the n consecutive integers. Then the previous one would be 3 to the n minus 1. Just give me 1 second. There's 7 of these. Okay. Now I see why I got confused. Because I'm using k and I was using k before, but now k is the power. So let's use m. So we want to write 3 to the n using 3 to the n consecutive integers. We don't know what our m is. So we're going to have m, and then prior to m, we're going to have m minus 1. Then past m, we're going to have m plus 1. And we're going to go all the way up until 1 less. So we're going to have, remember what we did before. So let's come over here. When we just started, when we had the example of, which one do I want? 27. We had our middle term, and we went down how much? We went down half of how many consecutive integers we wanted, right? So when there was 27, we had the middle, we went down halfway, and we went up half that many. So now what we're going to do is I'm going to go up half that far. We want to write 3 to the n consecutive integers here. So we're going to go all the way up to half that many minus 1. Okay. What's with the minus 1? Again, remember the 27 case. This was one term. So we have 1 fewer. And then we go up half that many. So when we had 27, it went down to 26, which was 27 minus 1. And we did half of that in both directions. And that's how we got 13 before. So we're doing the exact same thing, right? We have our middle term m. We're going to go all the way up to half of what's left over. And we're going to go all the way down to half of what's left over. So that's precisely what we're doing here. Okay. So this goes all the way down to m. Okay, running out of room there. Let me just give myself some breathing room. So we're going to go all the way down to m minus 3 to the n minus 1 down here, the whole number minus 1, all over 2. And this whole thing needs to be equal to 3 to the n. Okay. And, right, we have letters here, right? So this could be anything. Let's assume m is actually equal to 1, right? We're just going to see what happens. Suppose m is 1, and we have this whole list, and we want to see, does this indeed come out to what we want? Does this indeed come out to 3 to the n minus k, right? Let's see. So this is 1 minus 3 to the n minus 1 over 2 plus, right, dot, 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 plus 0, plus 1, plus 2, plus 1 plus 3 to the n minus 1 all over 2. Okay. And so what you're going to see is that what's going to survive, right? The previous term here is going to be a minus 1. The term after this one would have been m minus 3 to the n minus 1 plus 1, because it'd be 1 bigger, right? And so when I plug in 1 here, the next term would be 2 minus 3 to the n minus 1 all over 2, right? And so we've got 0 and 1 and 1, and then 2 and 2 going in both directions. Okay, let me take a peek at the chat right quick. What if n is even, though? Well, if n is even, that's fine, right? Because in the case that n was even, for example, if n is even, 3 squared would be 9, right? Or you could have 3 to the 4th, which is 81. And we wrote those numbers as sums of consecutive integers before, right? Do you want to unmute and if let me know if that made sense, or if you were thinking of another problem with n being even?
No, I think I got it. I was just like, well, I just got it. Well, it just happened in my mind. Well, yeah.
Yeah, no, that's good. If there's anything that's like, wait, what about if this? Please do share that, right? Okay. So if you go through this, right, and you look at everything that we have, then everything over here is going to come out to be 3 to the n minus k. So I'm going to leave that to you to double check that to see that that actually happens. Right? So check that, right? But what does that then give you? Let's look at that. That then gives you 3 to the n is equal to 3 to the n minus k. What am I going to get if I divide both sides of this by 3 to the n minus k? I'm going to get 3 to the n minus k on both sides. Okay. On this side, that's just 1, because these will cancel. And I have 3 to the n minus n minus k. Okay. Well, that is 3 to the n minus n plus k. The n's cancel. And so I get 3 to the k equals 1, right? So if m equals 1, then really we have a sum here, a partition for 1. And you can play around with this with different m's and see what you get. The heart of the matter, again, is that as long as you are using powers of 3, then you're going to be able to set this up. Okay, that's the main takeaway. So the next thing we're going to do is powers of 2, right? And it's going to be the same type of thing we're going to build up. So we can go a bit quicker because it's going to be the same idea. But are there any questions right now? Okay. Clarifications, anything? Okay. So let's start with 2 to the n. So let's do the exact same thing that we did before. Notice we're going to talk about doing consecutive odd integers. So we'll start off just assuming that's what we're going to do. We'll see why that needs to be put in there, though. So let's start here. We want to express each of these numbers as the sum of 2 consecutive, and again, odd integers. So when we had 9 and we did 3 consecutive integers, right? We had 2, 3, and 4.
Go diagonal to the, out to this side like that, where they're going to go and place down 1, 2, 3, and 4.
I'm sorry, could you repeat that, Logan? Or Benjamin, whoever that was, if that was intentional.
That was my bad. I accidentally unmuted.
Okay, no problem, no problem. Okay, so we want to write this as a sum of 2 consecutive odd integers. Okay. So go ahead and message us. Whoever gets one first, we'll go ahead and do, because it's very similar to before. Look at my chat here. Yeah, so Amal, do you want to go ahead and share what you got for these?
Yeah, 7 and 9 for the first one, x plus 2, 2x plus 2, subtract 2, divide by 2, you get 7, and then add 2 to get the next one, so 7 and 9, and then the next one is 31 and 33.
Okay.
Well, same process, except it's 64, so 62 divided by 2, and then add 2. 63 and 65, subtract 2, divide by 2, and then add 2.
Okay, so as you could probably tell from my face, that the process you used sounded correct, but you said it really quickly. So
yeah,
come back. Can you tell me that process right quick, but not
okay. So the first integer is x, and then since it's odd, you have to add 2, so you get 2x plus 2 as the sum. So 16 is equal to 2x plus 2. Subtract 2 to get 2x equal to 14, and then divide by 2 to get 7, and then add 2 to get the second integer. And then for the next one, it's the same thing. So 64 equals 2x plus 2. Subtract 2, and then divide by 2, you get 31, and then add 2 to get 33. And
Very
then
good.
the same one for 128.
Thank you. Yes, that's correct. So it's similar to before. We just assume we have the sum written in the abstract with k's, and then we use it to get what we need. Now, thinking of kind of what we did before, does anyone notice anything special about these numbers, 16, 64, and 128?
They're powers of 2.
They're powers of 2. Does everyone see that? The 128 might be a little tricky, right? But these are powers of 2, so that's going to be relevant. But our approach is the same idea. Each of these, they're equal to some number plus that number plus 2. Okay. So we want to express 2 to the n as a sum of 2 consecutive odd integers. Okay, so we had our warm-up. Let me make sure I am in order with my notes and not turn myself around. Okay, good. So see if you can do this, right? This looks like we jumped up more than we did with the 3 to the n. But in this case, with the 2 to the n, sum of 2 consecutive odd integers. Give me the formula for that. And let's do Maria, whoever gets to you first.
All right, sounds good.
Okay. So Maria's going to call on someone, send her your answers.
Already got an answer.
All right, go ahead and share it.
Amal?
Yeah, okay. Well, if you looked at the previous one, so if you looked at the 16, you get 7 and 9. And then if you take the average of 7 and 9, you should get 8. And then if you look at 16, which is 2 to the 4th, and then 8 is 2 to the 3rd. So, and then look at the second one as well. And then you should get 2 to the 5, and then also 2 to the 6. So in the formula, you should do 2 to the n minus 1. And then add 1 for the second integer, and then subtract 1 for the first one.
Okay, so yes, all of that's correct. Let me give a much more direct way to get that rather than the averages. Nothing's wrong with that. That is actually what's going on. But here's a much more direct way to get it, which is to just do this again, right? So if I want to write 2 to the n, and I'm going to use x like you did, so I don't confuse myself when I need to use k for something else later. So if I write this as a sum of 2 consecutive odd integers. Notice odd integers, okay? So I would do 2x plus 1, because it need, 2x plus 1, there's different ways to write this, plus 2x plus 3, right? Which is really 2x plus 1 plus 2, right? So I need them both to be odd, right? We got that for free on the last example. And then I'm just going to solve this for x, and that will tell me my two consecutive odd integers. So this will be 2 to the n is equal to 4x plus 4. Okay, what would I do next? Someone other than Amal, what would I do next to solve this? Just go ahead and jump in and unmute yourself.
Subtract 4 from both sides to isolate x.
That works. What would you then do next?
Divide by 4, which is 2 to the 2 squared.
There we go.
2 to the n minus 2.
Very good. So I can split that, right? And then what we get is 2 to the n minus 2 minus 1 equals x. So that's my x. And I can simply put that into both of these to have my two consecutive integers, right? And we're going to get precisely what Amal was describing. So if I plug this in, let's turn the page. We're going to get 2 times, let me go back. We're going to get 2 times x, which is 2 to the n minus 2 minus 1, 2 to the n minus 2 minus 1, plus 1. If I multiply that, I get 2 times 2 to the n minus 2 minus 2 plus 1. That's 2 to the n minus 1 minus 1. So that's my first integer. And if I plug this into this one, we get the same thing, but plus 3 instead. So when I plug that in, instead of having plus 1, I'll have plus 3 right here. So my next consecutive odd integer will be 2 to the n minus 1 plus 1. And so if I just add those together, that's going to give me 2 to the n, and I've expressed it as the sum of two odd integers. Does that make sense? Are there any questions? Does it not make sense? Right? Anything should go deeper into? Okay. Okay, very good. So what about expressing 2 to the n as the sum of 4 consecutive odd integers, right? So give that a try. Okay. So let me do this. I need to go to the bathroom. Let me run and do that. And when I come back, someone's going to share what they have. Okay, that should take me about 1 minute. So I'll be right back.
You can message either Connor or I, and you can also message us any questions that you might have.
Okay, so.
I got one response.
Okay, I had one and I just got one when I got back.
Okay.
So they look very different. Let me stare at them for a second. Okay. Maria, do you want to call on whichever one you got?
Anisha?
So I'm not really sure about this one, but so I divided 2 to the power of n by 2 to the power of 2, which is like 4. So then I got 2 to the power of n minus 2.
Okay.
And so for the 2, like on the bottom, I just minus 1 and minus 3. So like the bottom one, I put 2 to the power of 2n minus 2 minus 3.
So 2 to the power of 2n minus 3, you said?
2 to the power of, hold on.
You're good. So probably you have it written. It's just the phrasing, right?
I have it actually sent to you, Alex, if you want to see exactly what she wrote.
Okay. Ooh. Okay, very good. So the way you would say that, go ahead and say the first one that you were saying.
So I did 2 to the power of n minus 2,
Mm-hmm.
and the whole thing minus 3.
There we go. Yes. And then?
And then 2 to the power of n minus 2, and the whole thing minus 1. And then the 2 to the power of n minus 2, whole thing plus 1, and then same thing but plus 3 instead of plus 1.
Okay. Yes. And it was jumping by 2s because odd integers, right?
Yes.
So question, did you do that process I did before, or did you observe the pattern that we had and then just went down one more because there's twice as many terms?
Yeah, I just observed the pattern.
Okay. Yeah, because this was kind of annoying, right? Having to find the x and distribute the 2 in. Yeah. Does anyone have something different that they want to share? Or does anyone have any questions on this as our expression for 2 to the n using 4 consecutive odd integers? Okay. Okay, so let's do just a concrete example right quick, right? Can we express 128 as the sum of 4 consecutive odd integers? Now, because it's hit 830, let's do this one. And then let me double check something on what we'll do next. So do this one, send your answers to either Connor or Maria. I'll let Connor call on someone to share how they did it. Okay, so Connor's your guy. Oh, and actually after this, it's the last one. So we'll go ahead and do it, running a little bit long.
All right, Amal, do you want to show your answer?
Yeah, I got 29, 31, 33, 33, and 35.
Repeat them. I'm sorry. 29.
29.
Okay.
No, 29, and then 31, 33, and 35.
And how'd you get them?
So I made 128, 2 to the 7th, and then like the process that we did for the last question, 4 is 2 to the 2nd. Divide it so you get 32, and then add 1, add 3, and then subtract 1 and subtract 3.
Yep. So just using the formula, basically, right?
Yeah.
So very good. Yeah. So just so everyone else can see, 29, where that came from is it was not 3, it was 2 to the 7, because 7 is our n in this case. So 7 minus 2, which is 5, and then minus 3, and then that minus 1, and so on. And since these numbers are small, we can actually compute that instead of leaving it in the abstract. And so 2 to the 5th is 32. So this is 32 minus 3, which is 29. 32 minus 1, which is 31. 32 plus 1, and 32 plus 3. Very good. Okay, so you guys know what's coming, right? We just did an example with numbers. So now we ask the same type of question that we asked for 3 to the n, right? And the question that we had asked for 3 to the n was, can we do as long of a sequence as we want? Can we add as many terms as we want, right? We did 2 to the n with 2 consecutive odd integers. We did 2 to the n with 4 consecutive odd integers. And of course, we want to know, could we use 6, right? Is there a restriction on how many there have to be? And you can probably predict what's coming, right? Because we're at the 8:30 mark, I'll jump the gun a bit here. But with 3 to the n, we could only do it when it was divisible by 3, right? 7 didn't work. So 2 to the n, the same kind of thing happens. We can write 2 to the n as a sum of 2 to the k odd consecutive integers, as long as k is less than n, right? So it's the same kind of idea as for 3 to the n. One difference here is k has to actually be less than n, right? So notice that actually has to be smaller. And I got turned around on the proof for 3n and we're at 8:30. So I'm going to abstain from that. I do apologize for getting turned around on that proof earlier, but I hope everything else made sense. You should try to prove this on your own for fun. And something else just to think about, right? Besides 2 to the n and 3 to the n, can you make similar statements for other numbers? What about 4 to the n and 5 to the n and 6 to the n, right? What possible difficulties could there be here? And in particular, think about 6 to the n, right? Because we worked with 2 to the n and 3 to the n, right? So think about how these might be related. And if there's something you might be able to say, right? Or maybe stuff goes wrong and doesn't work, and you can give examples of that, right? That's what you should do if you're like, how does one do mathematics? Well, for every question you've solved, you then say, all right, well, what if I change this? What if I take two things I know and stick them together? How far can I go with this? That's sort of the natural question you should ask yourself as budding mathematicians. Even if you're not budding mathematicians, if you would just like to see what it would be like, that's the mentality or the thinking that you should use. So we have hit 8:30. Before I officially end, I'd like to ask, does anyone have any questions on this right here? What we've covered today? Okay.
Oh, I have a question. Are you gonna send the recording for this?
Dr. Kwon, goes to you.
Yeah, I will do that.
Okay.
Okay, thank you.
Posted. Okay. All right. So we've ended. Go ahead and switch your chat to be to everyone and type your first name, your last name, and goodbye or something to that effect so that we can take attendance, right? So using attendance, we can keep track of how many of these that you've been to, send out those certificates or whatnot if you were looking for that sort of thing and what have you. So go ahead and do that. Let me pause the recording.